Section 5.8 Electro-Cyber-Dome Security Concept. Power lies not in resources, but in the ability to change behavior. As the instruments of power change, so do strategies. Joseph Nye. Section 5.8.1 Imposing infinitely scalable physical costs on computers, programs, and computer programmers. Like all strategic security, a peaceful period of reprieve against attack or exploitation happens at an equilibrium point where BCRA is sufficiently low because cost of attack is sufficiently high. Successful deterrence is achieved not because would-be attackers can't perform an attack, but because they find it impossible to justify the physical cost of performing an attack. This happens when the attacker's opponent has successfully demonstrated they have both the means and inclination to impose severe physical costs on their attacker. Because there's theoretically no limit to the difficulty of solving hashing algorithms, that means there's theoretically no limit to the amount of physical cost that people and programs can impose on their attackers using physical cost functions. And because the physical cost is imposed electronically rather than kinetically, there are comparatively little practical limitations either. It goes without saying that this could have enormous strategic implications, which will be discussed further at the end of this chapter. Recalling the concept of the infinitely prosperous organism discussed in section 3.7, the reader should note that physical cost functions represent an infinitely scalable physical cost function. Since there's no theoretical limit to how much physical cost can be imposed by physical cost function protocols like Bitcoin, that means there's theoretically no limit to how much prosperity margin can be created by organizations utilizing this technology. Moreover, because the physical cost imposed by these systems is generated electronically rather than kinetically, that means there's also no threat of hitting a kinetic ceiling, no matter how efficient people get at imposing these physical costs. See sections 4.11 and 4.12 for a more thorough explanation of these concepts. The potential of physical cost function protocols like Bitcoin are therefore extraordinary because they don't have the same theoretical or practical limitations of traditional power projection tactics, techniques, and technologies used for physical security applications. All computers, programs, and computer programmers need to do to impose severe, real-world, physically prohibitive costs on other computers, programs, and other computer programmers in, from, and through cyberspace is simply create a firewall-style application programming interface, API, which utilizes an open-source physical cost function protocol like Bitcoin. The author calls this concept a proof-of-power wall and illustrates it in Figure 70, design concept of a proof-of-power wall cybersecurity API. Proof-of-power wall protocols could work by simply rejecting all incoming control signals that don't present proof of power. This would guarantee that all control signals sent across the API have low BCRA and are therefore more systemically secure against exploitation and abuse. By throttling up or down the physical costs incurred for each proof of power receipt, which could be done by adjusting the difficulty of the hashing algorithm or requiring more proofs of power, it would be possible to raise or lower the BCRA of each control signal as needed, thus increasing or lowering prosperity margin as desired. So long as the BCRA of authorized control signals are lower than the hazardous BCRA level, the computer program remains strategically secure against systemic exploitation. Recalling the core concept of the survivor's dilemma discussed in section 3.6, the hazardous BCRA level for any given environment cannot be known and tends to drop over time, causing a natural and continuous decline in prosperity margin. Organisms and organizations must strive to continually increase their cost of attack as much as they can afford to increase it, to ensure they can lower their BCRA as much as possible and buy as much prosperity margin as they can to remain systemically secure. This is a fundamental challenge of all strategic security that has stressed life for 4 billion years. Applying the same concept to physical cost function protocols like Bitcoin, we can see that hashing algorithms should be designed in such a way that their difficulty is continuously adjustable. That way, it is always possible to increase the physical difficulty of solving them, thus always possible to increase their cost of attack. This will ensure that people can permanently decrease the BCRA of their computer programs and buy as much prosperity margin needed to keep control signals systemically secure against exploitation and abuse. If sensitive control signals start to be exploited, people can simply increase the difficulty of the hashing algorithm to increase the amount of power needed to solve the cost function. Section 5.8.2 Building an Electro-Cyberdome Security System. Bitcoin is a swarm of cyber hornets serving the goddess of wisdom, feeding on the fire of truth, exponentially growing ever smarter, faster, and stronger behind a wall of encrypted energy. Michael Saylor. As previously discussed, the first proposed use case for cost function protocols was to serve as a countermeasure against DOS attacks, specifically email spam. This was something that multiple computer engineers recognized as a simple and attractive use case. Adam Back originally called proof-of-work stamps rather than proofs. The name stamp was chosen because the original use case of his protocol was to improve email services. The term stamp also highlighted how the proofs generated by his software aren't sequentially reusable, just like real mailing stamps aren't. The term proof of work didn't appear until 2 years after Back introduced his prototype. Only after proof of work became organically popular terminology did Back call his design concept a proof of work protocol. It didn't take long for people to start exploring how to use physical cost functions for other use cases beyond securing email browsers against spam. Some software engineers started exploring how to create physical cost function protocols to create sequentially reusable and transferable proof-of-power receipts. When this happened, people abandoned the word stamp and started using the names of other abstract objects like token or coin. These semantic specifications provided a more intuitive explanation of the software's emergent behavior because tokens and coins are both sequentially reusable and transferable. Nevertheless, the general function of physical cost functions and proof-of-power receipts remained the same, to make exploitable control signals more expensive to exploit, particularly the ones exploited during DOS attacks. This is why Back entitled his 2002 paper, Hashcash, a denial of service countermeasure. The general public frequently does not understand that proof-of-power protocols are first and foremost cybersecurity protocols, designed to defend computer programs against cyber attacks like DOS attacks. Back's Hashcash design concept, which explicitly called it a DOS countermeasure in the title, was reused in Bitcoin and was directly cited by Satoshi Nakamoto as a primary inspiration. Additionally, proof-of-power was universally described as a cybersecurity protocol for 15 years of peer-reviewed academic literature prior to the release of Bitcoin. In other words, proof-of-power protocols have been known as cybersecurity protocols for twice as long as they have been known as monetary protocols. As previously discussed, because there is close to no marginal cost required for modern computers to send control signals through cyberspace, it is possible for belligerent actors to target computer networks and flood them with superfluous control actions, for example, service requests, to overwhelm network bandwidth. One possible countermeasure against this type of attack is to ignore the control signals coming from the belligerent computers. However, this countermeasure is easily circumnavigated by sending belligerent control signals from different networks in what's known as distributed denial of service (DDoS) attacks. Using a proof-of-power wall API, aka a proof-of-power protocol, it is possible to apply a physical cost uniformly to all incoming control signals, creating a potentially more effective countermeasure against DDoS attacks. No matter how distributed an attacker's computer network can be, it would be equally as physically costly for them to spam a target network with superfluous control actions, because they would be required to attach a proof-of-power receipt, or stamp, or token, or coin, or whatever arbitrary abstraction the reader finds most helpful, to every malevolent control signal. And because DDoS attacks send substantially more control signals than honest users, it would be possible to throttle the physical cost exponentially higher, so that it's inconsequential for honest users, but severe for belligerent actors. By creating an email protocol which doesn't allow emails to reach someone's inbox unless they have a proof-of-power stamp, it's possible to cause the physical cost of sending someone emails to rise to levels where it would be too physically expensive to spam people's inboxes. The operational expense of generating enough proof-of-power stamps would simply be too high to make email spam, or any kind of spam, a profitable endeavor. It's a simple strategy. To prevent superfluous emails, make them superfluously expensive to send. Of course, proof-of-power wall APIs could theoretically be used to secure people against any form of systemic exploitation and abuse of any kind of software control signal issued by any computer, not just against email spam specifically. This is because all forms of hacking and software abuse are the result of inefficient control structure designs, which do not adequately eliminate or constrain unsafe control signals or insecure control actions. Email spam, comment spam, Sybil attacks, bots, troll farms, and weaponized misinformation stem from the exact same types of core design flaws, which proof-of-power wall APIs could theoretically help to alleviate. At the end of the day, a leading root cause of these attacks is a lack of ability to physically constrain control signals, and that capability is precisely what physical cost function protocols provide. Each of these types of attacks represents ways to systemically exploit computer programs by taking advantage of high BCRA control signals, like sending superfluous emails, posting superfluous comments, casting superfluous votes, and publishing superfluous information. Thus, each of these attacks could possibly be mitigated by adopting proof-of-power wall APIs, which make these malicious operations superfluously costly in terms of the number of watts required to send them. In plain language, proof-of-power APIs make it so that bad guys literally don't have enough power, aka watts, to launch or sustain their attacks. This electro-cyberdome concept is illustrated in Figure 71, illustration of the electro-cyberdome concept using proof-of-power wall APIs. An electro-cyberdome is a passive power projection tactic like the pressurized membrane concept developed by life's first organisms during abiogenesis, as discussed in Chapter 3. This simple barrier works the same way as a cellular wall or other passive power projection systems. It utilizes the computational inefficiency of cost function protocols to increase the amount of physical power, watts, needed to successfully attack or penetrate a target's API. A major difference is that electro-cyberdomes are non-kinetic physical energy barriers with no mass, built to function in an abstract domain called cyberspace. An electro-cyberdome has no force, mass, or volume, and is therefore completely incapable of causing physical injury. Nevertheless, an electro-cyberdome is still capable of projecting physical power and imposing severe physical costs on attackers in the form of electrically generated watts. On the flip side, it should be noted that this wouldn't be a strictly defensive power projection capability. The author is not even aware of any power projection capability which is strictly defensive, as even passive power projection tactics like walls are among the most successful offensive strategies ever used, hence all colonized territory. People with access to proof of power can theoretically smash through these electro-cyberdome defenses if desired. Thus, proof-of-power protocols are not strictly defense-only protocols, as some have argued. A top threat to people using physical cost function protocols like Bitcoin is other people using the same protocol. Hence why Nakamoto mentions the word attack 25 times in an 8-page white paper, each time referring to people running the same protocol. Instead of physically constraining attackers via forces displacing masses like normal barriers do, electro-cyberdomes physically constrain attackers via electric charges passing across resistors. But, as Einstein famously observed, matter is swappable with energy, so kinetic physical constraints can theoretically be swappable with electric physical constraints for certain applications. Physical power is physical power, regardless of whether watts are generated kinetically or electrically. Thus, the physics behind electro-cyberdome security systems is similar to any other physical barrier, even though it doesn't look anything like a traditional physical barrier. Just like any other physical barrier, Electro-cyberdomes secure themselves against attackers by increasing the number of watts attackers must expend to succeed. Security is achieved the same way it's always achieved, using any other kind of physical barrier. At a certain threshold, attackers simply don't have enough physical power to succeed. The armor is too strong, the moat is too wide, the wall is too tall, or in this case, the amount of electric power needed to send belligerent control signals is simply too high. Go to practically any popular website today and look at the comment section. You'll probably see many fake comments posted by many fake accounts, upvoted to the top of the page by many fake likes, all produced by computer programs, bots, or a small percentage of the population, often orchestrated by people trying to affect behavior or influence people's perception of reality. Part of the reason why this type of systemic exploitation of cyberspace is possible is because of how computationally efficient computers plugged into the internet have become. There's essentially no physical or marginal cost required to change the states of state machines or to send these control signals. In the real world, people can't sustain attacks like these because they simply aren't powerful enough. The real world has severe physical limitations and physical opportunity costs. In the current version of cyberspace, there are no such physical limitations. This could change if websites were to adopt electro-cyberdomes. They could create a physically constrained area of cyberspace where they would be protected from belligerent actors who routinely exploit cyberspace's lack of physical constraints. It would be possible to make it too physically expensive for belligerent actors to continue their malevolent operations on these websites, while simultaneously keeping costs low enough to preserve honest people's ability to use these services. By applying minuscule, superfluous physical constraints to actions taken online, could dramatically reduce the level of systemic exploitation and abuse currently plaguing the internet. Everything from email spam to state-sponsored weaponized misinformation could theoretically be physically constrained using proof-of-power wall APIs and electro-cyberdomes. We know for sure that electro-cyberdomes can function successfully as a security protocol because this is what Bitcoin uses to secure itself and its own bits of information against systemic exploitation. Like many things in software, Bitcoin utilizes a recursive system design. It calls its own physical cost function protocol to secure itself against systemic exploitation of itself. By using its own proof-of-power electro-cyberdome design concept to secure itself, Bitcoin has managed to remain operational for 13 years without being systemically exploited. In other words, hacked. It's not that people don't know how to exploit or hack Bitcoin's ledger. It's that it's impossible for attackers to either justify or overcome the immense physical cost, aka watts, of exploiting Bitcoin's ledger, because it's parked behind an electro-cyber dome. People literally don't have enough watts to gain centralized control authority over the protocol, to include nuclear-armed nation-states. This concept is illustrated in Figure 72. Bitcoin is a recursive system which secures itself behind its own electro-cyber dome. Section 5.9. Novel computer theory about Bitcoin. Satoshi opened a portal from the physical realm into the digital realm, and energy began to flow into cyberspace, bringing life to a formerly dead realm consisting of only shadows and ghosts, bringing conservation of energy and matter, objectivity, truth, time, and consequence into the digital realm, delivering property rights, freedom, and sovereignty. Michael Saylor. Following the operational success of Bitcoin, several new computer theories regarding physical cost function protocols, aka proof-of-work protocols, have emerged. Just as new theories emerging throughout the early 1930s eventually became foundational to mainstream computer science, today's new computer theories regarding physical cost function protocols could one day become foundational to mainstream computer science as well. The goal of this thesis is to present an overarching, grounded theory on the socio-technical implications of physical cost function protocols, and to understand how they could influence cybersecurity and national strategic security. The core concepts of this overarching theory are grounded to more technically detailed theories discussed in this section. Some of these ideas were inspired from data collection, but others are completely original. The most important takeaway from this technical discussion is that Bitcoin, the system, may not only be special because it represents a new type of software, but because it represents a new type of computer. The author believes that Bitcoin represents the invention of what he calls a planetary state mechanism. Section 5.9.1 Computational inefficiency has complex emergent benefits that few understand. What we obtain too cheap, we esteem too lightly. Thomas Paine. As of this writing, the fastest operational computer can transmit data at a rate of 1.84 petabits per second, making it fast enough to transmit the entire world's internet traffic in well under 3 seconds. This type of speed is possible because an unspoken assumption of computer engineering is that we should endeavor to build more physically unconstrained and energy-efficient state mechanisms with larger and larger state spaces, so that they can process as many bits of information as quickly and as cheaply as possible. Here's an interesting question. What's the slowest and most energy-inefficient computer in the world? Why don't we measure that or celebrate that machine? Rarely do engineers discuss the strategic value of endeavoring to build the biggest, slowest, and most energy-intensive computers with smaller and more physically restricted state spaces that have extremely difficult-to-change state mechanisms. Generally speaking, computational slowness and energy intensity are not valued. Few recognize the strategic benefit of creating increasingly more costly bits of information in a domain flooded with increasingly less costly bits of information. Notably, few articles are written by engineers celebrating how much power a computer has to consume to change its state or to send a command. There seems to be a universal bias for smaller, faster, and more energy-efficient computers because of an unspoken assumption that such devices are always better for every possible computing application. Incidentally, one of the rare groups of people who appear to understand the value of superfluously difficult computing and to celebrate how computationally expensive it is to transfer, receive, and store bits of information are Bitcoin enthusiasts. This is very noteworthy. Bitcoin enthusiasts have emerged as iconoclasts who are not only unapologetic about the Bitcoin computing network's superfluous energy usage, they also celebrate how computationally difficult it is to run the Bitcoin network. Why do these people consider Bitcoin's extreme computational difficulty to be a virtue, while mainstream computer scientists appear to be adopting a stance that Bitcoin's energy intensity is somehow bad? Section 5.9.2 Leveraging the planet's global power infrastructure as a physically decentralized and thermodynamically restricted computer. Recalling the core concepts presented earlier in this chapter, modern computers are stored program general-purpose state mechanisms. Computers work because engineers learned how to apply symbolic meaning, for example, Boolean logic, to physical state changes created by miscellaneous state mechanisms by inventing a new language called machine code. One of the main reasons why machine code is so remarkable is that it allows people to convert practically any physical phenomena into bits of information that can be transferred, received, and stored using practically any form of physical state-changing mechanism. The key takeaway from this deep dive into computing was to develop a foundational understanding that, thanks to machine code, practically any state-changing phenomena in nature can be utilized as a programmable computer, as well as a medium through which information can be transmitted and received by a computer. This explains why the physical form of general-purpose stored program computers has been able to change so dramatically over time. Whereas early computer engineers like von Neumann worked with massive machines and large plug boards, modern computer engineers work with microscopic floating gate transistors on circuits smaller than a fingerprint. The size, weight, and energy requirements of computers have changed dramatically over the years, as computer engineers discover new ways to manipulate their physical environment. Nevertheless, machine code has remained the same. The past 80 years of computer engineering could be generalized as a search for the fastest and most energy-efficient state-changing phenomena. State mechanisms with larger state spaces are treated as though they are unquestionably better because they have more memory. Likewise, state mechanisms with easier-to-change states are treated as unquestionably better because they are cheaper and faster to operate. Generally speaking, the ability for computers to transmit more data, receive more data, and store more data on increasingly smaller devices is universally considered better. There has been little consideration if it would be useful to reverse optimize the design of a computer. Computer engineers' obsession with faster, cheaper, and smaller computers is what drove them to turn the fastest known movable physical phenomena in the universe into a physical state-changing mechanism for use in computers: light. The reason why computer engineers have successfully managed to build computers which can process 1.84 petabits of information per second is because they leverage light itself as the state-changing mechanism to encode, transfer, receive, and store bits. As of this writing, the fastest computer chip works by encoding bits of information into light, by applying machine code to modulated amplitude, phase, polarization, and wavelengths of transmitted light. Just as it is possible to create faster and more energy-efficient state mechanisms by leveraging faster and more energy-efficient phenomena of the natural environment, it should also be possible to create larger, heavier, slower, and more energy-intensive state mechanisms by taking advantage of the larger, heavier, slower, and more energy-intensive physical phenomena of our natural environment. All a computer engineer would need to do is find the appropriate physical state-changing mechanism, then apply Boolean logic to it. We have now established two key points that are essential to understanding the computer theory behind protocols like Bitcoin. The first key point is that people with their extraordinarily gifted capacity for abstract thinking can apply the Boolean logic of machine code to practically any physical state-changing phenomena to turn it into a programmable computer. The second key point is that for decades, computer engineers have been operating under an unchallenged assumption that smaller, lighter, cheaper, faster, and more computationally and energy-efficient computers are always better for computing applications. There has not been significant research towards exploring the idea that there could be major complex emergent benefits to society if they were to design and build a massive scale, heavy, slow, expensive, and energy-intensive computer network. Section 5.9.3 Planetary scale computation is theoretically feasible, and Bitcoin could be the key. A Los Angeles-based think tank called the Berggruen Institute has a program called Antikythera, named after the famous Antikythera mechanism, considered by many to be the earliest computer ever discovered. One of the primary goals of the Berggruen Institute's Antikythera program is to become a global leader in speculative philosophy surrounding the socio-technical implications of planetary scale computation, to include the geopolitical impacts of planetary computation and what its underlying platform infrastructure might look like. In their view, planetary scale computing could have extraordinary impacts on human society, including mind-bending implications like planetary sapience. If artificial intelligence were to reach a point where computers became sapient, and we were to combine this technology with a planetary scale computing platform, then it is theoretically feasible for the planet itself to become sapient and self-aware of its own existence. Many of the Antikythera program's speculative philosophies about planetary scale computing are outside the scope of this thesis, but the purpose of mentioning it is to illustrate the point that planetary scale computing is a legitimate concept that is actively being investigated by organizations that influence public policy. It isn't really a matter of whether planetary scale computing can be done, because we already know from computer theory that the Boolean logic in machine code can be applied to practically any physical state-changing phenomenon, to include the planet itself. It's pretty straightforward that planetary scale computing could be done. Instead, the mystery surrounding planetary scale computing is devoted to figuring out how it could be done, particularly what physical state-changing mechanism would be used, and how its operating system would work. A core hypothesis of this thesis is that Bitcoin is emerging as the base layer operating system and infrastructure of a planetary scale computer, and consequently a new form of physically constrained and thermodynamically restricted state space that can be added to the internet. If this theory is valid, then global adoption of Bitcoin simultaneously represents the global adoption of a planetary scale computer, the exact thing which speculative philosophers like the Berggruen Institute's Antikythera program theorize would have drastic geopolitical implications. It turns out the natural environment outside of our computers is filled with circuitry and physical state-changing phenomena that could be utilized for large, heavy, slow, expensive, and energy-intensive computing applications. Our surrounding environment is filled with state-changing phenomena that can encode, transfer, receive, and store machine-readable bits of information. It is therefore theoretically possible to utilize the surrounding environment and supporting infrastructure outside of our worldwide web of computers as a singular and superfluously cumbersome planetary scale computer in and of itself. Theoretically, all we have to do to accomplish this is figure out how to 1. Control its physical state, and 2. Apply Boolean logic to it, which is precisely what Bitcoin already appears to do. Not only would it be possible to utilize the planet itself as a large, heavy, slow, and energy-intensive computer, the infrastructure and circuitry required to accomplish this has already been built. We call it the Global Electronic Power Grid. Herein lies a simple but profound idea: to create the world's largest, heaviest, most energy-intensive, and most physically difficult to operate computer ever built, we could simply utilize our planet's energy resources as the controllable physical state-changing mechanism of a planetary scale computer, where the globally distributed electronic power grid serves as its circuit board. This design concept is illustrated in Figure 73, utilizing the global electric power grid as a computer. Bitcoin demonstrates that it's possible to create a computer program that is so computationally and energy efficient that it can lead to material changes to the state of the surrounding physical environment outside of the computers running it. Computer programmers could theoretically apply Boolean logic to these environmental state changes, converting them into machine-readable bits of information that can be fed back into ordinary computers. These ideas are valid according to modern theories of computation. By turning the surrounding environment outside of our ordinary computers into a state-changing mechanism, and then applying machine-readable code to these state changes, a computer network like cyberspace would be able to send bits of information and control signals into its surrounding environment, in other words, the planet itself, and receive control signals back from its surrounding environment. This technique would make it possible to convert the planet itself into a massive scale and globally decentralized planetary computer by utilizing 1. The planet's energy resources as the state-changing mechanism, and 2. The global electric power grid as its motherboard. This would qualify as a planetary scale computer that could be plugged into the existing internet, effectively adding the state of the planet's globally decentralized and thermodynamically restricted energy resources to the state space of cyberspace through the existing infrastructure of our global electric power grid. From a first principles perspective, it's a surprisingly simple concept. Cyberspace is, after all, nothing more than the state space of all the physical state-changing mechanisms plugged into it, and the global electric power grid is nothing more than a bunch of machinery that changes its physical state. This concept is illustrated in Figure 74, Planetary Scale Computer Design Concept. But what could possibly be the benefit of turning the electronic circuitry outside of our internet into a programmable computer in and of itself, and then plugging it back into the internet? The benefit is that it would create a physically decentralized and thermodynamically restricted section of the internet, over which agrarian society would be able to compete for control authority in a zero-trust, permissionless, and egalitarian way, using a physical power competition. As a complex emergent benefit of that physical power competition, the global population would be able to gain and maintain decentralized control authority over this special part of the internet. This is where the core concepts discussed in the previous chapter become critical to understand. With the invention of this type of planetary scale computer, agrarian society would be able to use their own energy resources to battle for control authority over this planetary scale computer, the same way all organisms in nature, including and especially modern agrarian sapiens, have always used physical power competitions to battle for control authority over resources. And as a complex emergent benefit of this ongoing electric power competition, agrarian society would be able to gain and maintain decentralized control authority over this new digital age resource. As established in Section 4.9, one of the primary value-delivered function of physical power competitions, aka warfare, is physical decentralization of control over Earth's natural resources. There's no reason to believe this wouldn't also apply to power competitions for control over the natural resources comprising a planetary scale computer. A planetary scale computer like this could theoretically create a portion of the internet where no single person or organization has full control over it. Thus, they have no ability to fully control the bits of information transferred, received, and stored on it. This decentralized portion of the internet could be reverse optimized to be more expensive and energy intensive to send, receive, and store every bit, giving it complex emergent behavior that no other computer connected to the internet would be physically capable of replicating. These features could become extraordinarily useful for digital age societies, which find themselves increasingly trapped under software-instantiated abstract power hierarchies, crowned by a technocratic ruling class of digital age god kings who wield asymmetric abstract power and control authority over the existing computers connected to the internet. Right now, these rulers must be trusted not to exploit people through cyberspace, because the population has practically no infrastructure in place to physically constrain software or impose severe physical costs on people, programs, and institutions operating in, from, and through cyberspace. digital age society also has no ability to use physical power as the basis for settling online disputes or achieving online consensus on the legitimate state of ownership and chain of custody of property. All this could theoretically change if society invented a planetary-scale computer that effectively converted the global electric power grid into part of the Internet. In short, it's possible to think of several reasons why people would benefit from a physically decentralized and thermodynamically restricted state space of the Internet, created by a planetary-scale state mechanism, which converts our electric power grid into the motherboard of a planetary-scale computer. Section 5.9.4. A planetary-scale computer could physically constrain other computers for improved security. Bitcoin enables conservation of energy in time and space because it enforces conservation of energy in cyberspace. Michael Saylor. The surrounding physical environment outside of our computers would make a very different kind of state mechanism in comparison to the ones inside our offices and our pockets. It would have very physically expensive to change states. It would require so many watts to change states that some populations would literally not have enough power to change the state of this mechanism. This would translate into computer commands that are not practically possible to execute, or bits of information that are not practically possible to replicate, alter, or exploit. In other words, it would create a mechanism that computers could use to physically enforce and physically secure computer programs. Open and egalitarian access to this type of special-purpose planetary computer could give digital age society the ability to physically enforce their policies, physically constrain sensitive computer signals, and physically secure valuable bits of information in a way that was previously not considered possible. Populations would be able to use it to impose severe physical costs on other people, programs, institutions, and even entire nations who try to systematically exploit them through their worldwide web of computers. This capability could only get more valuable as more people, institutions, and nations coordinate international operations via cyberspace, because they would be more vulnerable to the threat of those who keep trying to systemically exploit the Internet's existing architecture. Physically constrained computers translate directly into physically constrained computer programs, as well as physically constrained computer programmers. In other words, it's possible to physically constrain people in, from, and through cyberspace. It doesn't have to be done kinetically in three-dimensional space using forces to displace masses. Therefore, a thermodynamically restricted planetary-scale state mechanism would likely serve as a key enabling technology for physical power projection in, from, and through cyberspace. As previously discussed, the ability to project physical power to physically constrain computer programs and computer programmers in, from, and through cyberspace is notably missing in the design schematics of today's Internet architecture. If people were to build a planetary-scale computer like the one described here and plug it into the Internet, this could not only usher in new approaches to cybersecurity, but it could also dramatically change humanity's approach to national strategic security, particularly how it secures information and enforces policies and social contracts against exploitation. As previously discussed, one of the most challenging aspects of software engineering and cybersecurity is the inability to apply physical constraints to unsafe control actions, or to impose physical costs on belligerent actors. It would theoretically be possible to utilize an open-source, internet-accessible, planetary-scale computer to perform these functions. The key to doing this effectively would be finding a way to chain down or couple ordinary state mechanisms to this new planetary-scale state mechanism. In this design, the planetary-scale computer with superfluously difficult-to-change states would apply severe physical constraints and thermodynamic restrictions on normal computers connected to it via cyberspace, as well as the programs running on them. This design concept is illustrated in Figure 75, using a planetary computer to chain down regular computers. Section 5.9.5. A planetary-scale computer could dramatically improve society's global electric power grid. There's another major benefit of utilizing a planetary-scale state mechanism as a large, heavy, slow, and energy-intensive computer. If society were to create a planetary-scale computer which utilized global energy resources as its state-changing mechanism, akin to transistors, as well as the global electric power grid as its circuitry, akin to a motherboard, then society could theoretically unlock the benefits of Moore's Law for our energy infrastructure. Engineers love making their systems more efficient, particularly their computer systems. As previously mentioned, computer engineers are obsessed with optimizing their computer systems to make them faster, cheaper, and more energy efficient. This phenomenon is so predictable that we colloquially refer to it as Moore's Law. If society created a planetary-scale computer, then populations would naturally seek to improve the speed and efficiency of this computer's circuitry. Societies might search for cheaper and more abundant sources of energy with more optimized infrastructure designs so they could make their portion of the planetary-scale computer faster and more efficient. There would also be an incentive to do this to gain a competitive edge in the form of more control authority over the planetary computer as a whole. These dynamics would create a counterintuitively beneficial feedback loop for society. The wide-scale adoption of a deliberately large, heavy, slow, and energy-intensive planetary-scale state mechanism would motivate society to try to continuously improve it by creating faster, more efficient, and more optimized electric power infrastructure. In other words, the complex emergent benefit of turning the global electric power grid into the circuit board of a planetary-scale computer would be to unlock Moore's Law for the global electric power grid. By simply turning the power grid into a computer chip, society would be able to utilize its insatiable drive for faster and more efficient computer chips to create faster, more responsive, and more efficient power grids. Section 5.9.6. Software could utilize the environment outside of our computers as a computer in and of itself. With the potential benefits of planetary-scale computing fresh in our minds, the reader is invited to re-examine physical cost-function protocols like the one invented by Adam Back to further understand the author's assertion that Bitcoin could function as the operating system of a planetary-scale computer. There is a subtle but extremely important difference to emphasize between regular computer programs and physical cost-function protocols, aka proof-of-work protocols. Regular computer programs are designed to produce a single physical effect, a materially inconsequential transistor state change inside the circuitry of an ordinary state mechanism. However, physical cost-function protocols like Bitcoin are designed to produce an additional physical effect. Not only do they create transistor state changes inside of ordinary computers, they're also explicitly designed to create materially consequential state changes in the surrounding physical environment outside of our computers. This concept is illustrated in Figure 76. Difference between regular computer programs and physical cost-function protocols. It's incontrovertibly true that physical cost-function protocols like Bitcoin are so energy-intensive that they can directly influence the shape and structure of the surrounding electric power grid, a feature that has made Bitcoin infamous for its superfluously inefficient protocol by people who don't understand the complex emergent benefits of this design concept. Therein lies the key difference between normal software and Bitcoin that many people overlook. It's the fact that Bitcoin creates such a substantial physical change to the state of the environment outside of the computer on which it runs, which makes Bitcoin so extraordinarily different and unique compared to all other types of software. People mistakenly believe that Bitcoin's substantial energy intensity is a bug, but it's actually its primary value-delivered feature. The physical state changes of the surrounding environment produced by physical cost functions manifest themselves as deficits or vacuums of electric power, which must be filled by electric power producers connected to the global electric power grid. This quantity of electric power represents a continuous time signal that can be transferred, received, modulated, digitally sampled, and stored as digital information, just like any other power-modulated electromagnetic signal. The primary differences are simply power intensity and production cost. Just like the world's fastest computer chips transmit, receive, modulate, sample, and store electromagnetic signals in the form of electromagnetic light waves with low power intensity and low production cost, physical cost function protocols convert the electric power grid into a giant global-scale circuit board, which can transmit, receive, modulate, sample, and store electromagnetic signals in the form of large quantities of electric power with comparatively giant power intensity and production cost. From a first principles perspective, it's the exact same infrastructure, circuitry, with the exact same physical phenomena, electromagnetic signals, and even the exact same design concept, converting modulated electromagnetic signals into bits of information, but reverse optimized. Instead of using increasingly smaller circuitry and smaller amounts of electromagnetic power like normal computer networks, Bitcoin is intentionally reverse optimized to use increasingly larger circuitry, for example the power grid, and larger amounts of electromagnetic power. Using systems thinking, we can see that physical cost function protocols like Bitcoin function as a signal generator and modulator, which send digitizable signals to a planetary scale computer comprised of the global electric power grid. At the same time, physical cost function protocols also function as a signal processor, which digitally samples signals received from the planetary scale computer. The signals sent to the planetary computer take the form of large electric power deficits created by the computer network running the cost function protocol. In other words, the computers running Bitcoin, which can be modulated as desired by simply changing the difficulty of solving the cost function's hashing algorithm. The signals received from the planetary computer take the form of a digitally sampled proxy measurement of the quantity of electric power consumed by the network. For physical cost function protocols like Bitcoin, computational power is sampled by measuring the average hash rate over a specified time interval. In other words, instead of sampling the modulated electric power drawn from the electricity grid, Bitcoin samples how many calculations are being made by the computer network running it as a directly proportional proxy measurement. This design concept is illustrated in Figure 77. Bitcoin is a physical cost function protocol which utilizes the planet as a computer. Physical cost function protocols utilize the planet itself as a programmable computer, where the globally decentralized power grid functions as its motherboard, through which it sends, stores, and receives digitized information. These protocols can adjust the difficulty of their hashing algorithms to produce a modulated, continuous time control signal in the form of a modulated quantity of electric power drawn from the surrounding physical environment. These protocols appear to be able to digitally sample the power signal they receive from the environment and turn them into a machine-readable, discrete time signal. These digitized signals are broadcast to regular computers connected to the internet as regular bits of information, which can then be abstracted by computer programmers as anything they desire, just like all bits of information sent across the internet can be abstracted as anything the imagination is capable of thinking of. The bits can be described as a transferable object, like a proof of power receipt, with countless names like digital energy, bit watts, or bit power. They could also be called stamps, tokens, spoons, coins, bit stamps, bit tokens, bit spoons, or perhaps even bit coins. As always, what people call the bits of information passed across computers is semantic and arbitrary. It, literally, doesn't matter, because bits are not matter. What makes the bits produced by physical cost functions matter is not their name, but the matter used to create them. In other words, what is happening under the hood of physical cost function protocols at the state mechanism level is what matters, because it's materially different than what happens under the hood with other software at the state mechanism level. This design concept is illustrated in Figure 78, illustration of how physical cost functions convert quantities of power into bits. There are very real, very meaningful systemic differences between the bits of information created, transferred, and stored by normal computers and the bits of information created, transferred, and stored by a planetary computer. The primary difference is that these two very different kinds of bits of information have been reverse optimized. Whereas bits of information from a normal computer are optimized to be as cheap and easy as possible to produce, transfer, and store, the bits of information from a planetary scale computer are optimized to be as expensive and difficult as possible to produce, transfer, and store. It's the exact same technology and the exact same digitization process, but reverse optimized. Here we can begin to appreciate what could eventually become recognized as a primary implication of physical cost function protocols like Bitcoin. Bitcoin appears to set a precedent within the field of computer science by being the first globally adopted software to utilize the planet itself as a state mechanism, in other words, a computer, for the exact purpose of making bits of information increasingly more difficult to create, transmit, receive, and store. Physical cost function protocols accomplish this by creating state changes in the surrounding physical environment outside of the microchips contained within ordinary computers. They apply Boolean logic to massive quantities of electric power drawn from the local environment, treating the globally distributed electric power grid as if it were a state-changing circuit board. By applying Boolean logic to the power grid, people convert large and expensive quantities of physical power into bits of information, and feed that information back into our regular computers via the internet. People then use that information to effect state changes inside their ordinary computers. The result of this activity is a capability which does not appear to have existed before: the ability to impose severe physical costs and thermodynamic constraints on people, programs, and computer programmers operating in, from, and through cyberspace in a zero-trust, egalitarian, and permissionless way that no person or organization can fully control. People don't appreciate how special physical cost function protocols like Bitcoin are, because they are making the tacit assumption that all bits of information are the same. They think the bits produced by Bitcoin are the same as the bits produced by any other type of software. From a technical perspective, it's true that the bits produced by Bitcoin are generally the same as bits produced by other software. In both cases, people are simply applying Boolean logic to a modulated electric signal. However, people aren't paying attention to what's happening under the hood at the foundational layer of the tech stack, the state mechanism itself. So they aren't recognizing that a completely different physical phenomenon is generating Bitcoin's bits. Without paying attention to what's happening under the hood at a state mechanism level, it's hard to see how the bits produced by proof-of-work protocols like Bitcoin are unique, because they have been reverse optimized, giving them unique properties that are physically impossible to replicate by ordinary computers. Because people don't look under the hood, they overlook the fact that Bitcoin converts large and expensive quantities of physical power into bits of information. Physical power is converted into bit power, giving people the ability to wield real power in the abstract domain of cyberspace, while retaining the beneficial systemic properties of physical power. For example, cost, scarcity, decentralization, and thermodynamic restrictions. that can't be replicated by transistors in ordinary state machines. With physical cost function protocols like Bitcoin, the boundary separating the circuitry inside of our computers and the circuitry outside of our computers disappears. Our microchips and our power grid become one in the same technology, but headed towards opposite sides of the optimization spectrum. Gradually less materially consequential transistor states on microchips represent the side of the computational engineering spectrum that is being optimized to be as small, light, fast, and efficient as possible. Gradually more materially consequential quantities of electric power drawn out of the global electric power grid represents the side of the computational engineering spectrum that is being optimized to be as large, heavy, slow, and energy-intensive as possible. The result? Very different emergent behavior. With proof-of-power protocols like Bitcoin, two very different worlds are bridged together in one combined system. Our planet's largest energy producers become equivalent to state-changing transistors on a giant, global-scale, transnational, general-purpose computer, over which no person or organization can afford to have complete and unimpeachable control. Consequently, agrarian society itself becomes a living, breathing part of the Internet's hardware. As a result of this bridge, the abstract things we encounter in cyberspace no longer exclusively represent a complex emergent effect created by cheap and materially inconsequential transistor state changes on a microchip. They also represent expensive, materially consequential state changes in our surrounding physical environment that we can independently verify by simply observing the state of our civilian infrastructure. Physical cost function protocols, aka proof-of-work protocols, like Bitcoin, bridge our surrounding physical environment to cyberspace by effectively converting our surrounding physical environment into the state space of a computer and weaving it into the Internet. In other words, Bitcoin converts our three-dimensional space into a subspace of cyberspace. For the first time, agrarian society has zero trust and egalitarian access to physically constrained and thermodynamically restricted bits of information because the underlying state mechanism is physically constrained and thermodynamically restricted. We can pass these bits of information across cyberspace and use them however we want to use them to give our legacy cyber systems complex emergent behavior. For example, physical security, decentralization, and zero trust control. That is otherwise physically impossible for computers to replicate in cyberspace. Physical cost function protocols like Bitcoin therefore appear to function as both an operating system for a planetary scale computer as well as an application programming interface, API, between our computers and the planetary scale computer, aka the power grid, into which our computers are plugged. By creating this planetary scale computer, people appear to be adding a new, unique, physically constrained, and thermodynamically restricted state space to cyberspace that has never been seen before, and it's leaving people confounded. They don't know how to describe what they're seeing because they've never seen anything like it. Bitcoin appears to be bridging our shared objective physical reality to virtual reality by turning the planet itself into a computer which can be programmed and plugged back into the internet. This could theoretically allow people to import the physically constraining and thermodynamically restrictive properties of our surrounding physical environment into cyberspace, so that we can create real-world, materially consequential effects in, from, and through cyberspace. As engineers like Saylor, MIT 87, have observed, proof-of-work protocols like Bitcoin appear to have opened a portal between the physical realm and the digital realm. In doing so, these protocols appear to be importing properties from one reality to the other, in a manner that people apparently didn't think was possible. Section 5.9.7 Programs running on a planetary scale computer could program human civilization. Yet another potential benefit to be gained from turning the global electric power grid into a planetary scale computer and then plugging it into the internet is that it would effectively create a bridge between the virtual reality of cyberspace and the real-world objective reality of our surrounding physical environment. The state changes of a planetary scale state mechanism would represent materially consequential changes in shared objective physical reality, as opposed to materially inconsequential and virtually undetectable state changes in microscopic transistors. By utilizing large quantities of energy drawn from the environment as a state-changing mechanism and running computer programs on it, this would cause software to have a highly path-dependent and irreproducible realness to it that ordinary computer programs running on basic computers simply cannot replicate. By learning how to utilize the planet itself as a programmable state mechanism, abstract concepts in computer programming are no longer strictly abstract. Computer programs would be capable of changing the physical state of the surrounding environment in substantial ways, giving complex emergent behavior that is physically impossible to replicate by ordinary computer programs running on ordinary computers. The programs we run in cyberspace wouldn't just manifest themselves as images on a computer screen. They would begin to include major physical changes to the state of our surrounding three-dimensional environment, namely our global electric power grid architecture. This has already started to happen with Bitcoin. Instead of the images on our screens changing as we run our software, the infrastructure of agrarian society would change as we run our planetary scale computer software. In essence, the software running on a planetary scale computer would have the ability to program society itself. From a metacognitive perspective, turning the environment into a programmable computer would be a repeat form of bidirectional abstract thinking and symbolism discussed in the previous chapter. The symbolic meaning, Boolean logic, that sapiens applied to physical changes in shared objective physical reality would influence their shared abstract reality, and vice versa. By utilizing a planetary scale computer that converts our global civilian infrastructure into a shared state-changing mechanism, the emergent behavior of the software running on that planetary scale computer wouldn't be strictly virtual. The effects of planetary-scale computer software would correspond to real, meaningful, physical changes of the observable universe in front of our eyes, in addition to changes in the imaginary world behind our eyes, in the virtual domain of cyberspace. Once again, our abstract belief systems, our virtual reality, would change our behavior in physical reality. Except this time, our virtual reality would be the bits of information passing across the state space of cyberspace, corresponding to the planetary-scale computer we created. This concept is illustrated in Figure 79, bidirectional abstract thought and symbolism applied to a planetary computer. The idea of using planetary-scale computing software to program how humans behave and structure their surrounding environment sounds remarkable. But when we take the time to reflect upon human metacognition and the concepts introduced in the previous chapter, we can see that this is actually common human behavior. Human society already operates under large-scale consensual hallucinations. Society's abstract belief systems already dramatically influence social behavior, as well as the shape and structure of our physical environment. The wide-scale adoption of these shared abstract belief systems already explains why societies organize into imaginary abstract power hierarchies like nation-states, and then physically compete in wars. Nation-states are nothing more than shared virtual reality. They don't exist anywhere except within our collective imaginations. Therefore, humans have already adopted the habit of letting virtual reality govern their behavior on a global scale and influence how they structure civilization. Software running on a planetary-scale computer would essentially represent the exact same phenomenon, a common belief system that influences the shape, structure, and behavior of society itself. Section 5.9.8 Proof of power protocols are proof of real protocols. A planetary-scale computer could function as an internet grounding device, which grounds elements of our shared virtual reality, cyberspace, to physical reality, three-dimensional space. Large quantities of physical power represent something real, path-dependent, and materially substantial. When large quantities of physical power are used to transfer digitized information across the internet, then proof of that power expenditure doubles as proof of materially irreproducible state changes in shared objective physical reality. As discussed in the last chapter, proof of power protocols represent proof of real. After having reflected in the previous chapter about human metacognition and how sapiens detect if something is real, Section 4.3, the concept of using proof of power to represent proof of real in cyberspace makes perfect sense. Sapiens already use proof of power protocols like poking, pinching, or touching to prove or verify realness. Proof of real protocols are necessary because sapient neocortices are so effortlessly gifted at abstract thinking that it can be challenging to distinguish between real-world things and imaginary things. If a person ever finds themselves in a situation where they need to verify if something they encounter is real, the common protocol is to reach out and try to poke the thing. A key insight into the poking-pinching protocol is that it is fundamentally a proof-of-power protocol. When someone reaches out to touch an object to verify if it's a real thing rather than an imaginary thing, they are technically searching for a physical power signal. They are looking for the presence of watts. To poke something is to use energy to apply a force to displace mass across space and time. When someone pokes an object, they project power, aka watts. If the thing they're trying to poke moves or exerts an equal and opposite amount of force back at its observer, then the observer gains a cross-referenceable sensory input, aka synaptic feedback, needed to tighten their consensus that the thing they see does indeed physically exist, and is not just a figment of their imagination. Hence why companies are working on synaptic feedback systems to make virtual reality experiences feel more real. Why is a power signal so important for making online experiences feel more real? Because power is comprised of the core components of physical objective reality: time, space, matter, and energy. If a person can verify that physical power is present, then they can be much more confident that what they see is from the domain of physical objective reality, because they have verified to the best of their ability that the core components of objective reality are verifiably present. The object moved when it was poked, or the object pushed back. Therefore, the object must be real. How humans use proof-of-power protocols like poking and pinching illustrates a glaring capability gap for humans operating in, from, and through cyberspace. Cyberspace is a virtual reality. Virtual reality is, by definition, imaginary reality. When sapiens currently operate in cyberspace, everything they see represents nothing more than abstract meaning assigned to the state space of all the state machines connected across the internet. Connect billions of state machines together, and you get an incalculable number of states and state changes. Sum together the abstract meaning of that incalculable number of state changes, and you get the infinitely expanding imaginary reality of cyberspace. This domain is getting infinitely larger, faster, and cheaper to build. As this happens, cyberspace becomes infinitely more marginalized. When people operate online, their neocortices are deprived of cross-referenceable physical sensory inputs needed to verify realness. They have no way to generate a proof-of-power signal on their own, thus no way to produce a cross-referenceable sensory input to use as a proof-of-real signal, as illustrated in Figure 80, a capability gap for brains operating in the abstract reality known as cyberspace. Synaptic feedback systems don't help with this because they're equally as artificially generated as the symbols on a screen or the sounds from computer speakers. Without being able to manually generate a proof-of-power signal by users on their own in a zero-trust way that can be independently validated, nothing in cyberspace is capable of being validated as physically real or consequential. Cyberspace becomes strictly an imaginary dream state, nothing but abstract meaning applied to bits of information stored as inconsequential state changes inside an infinitely expanding state space. The abstractions pile on top of each other to the point where nothing observable in cyberspace can be unique or special. They are just programmed to present the illusion of being unique or special. Sapiens arbitrarily choose to describe the Internet as if it were a three-dimensional orientation of objects, because that's the easiest and most intuitive way for us to explain the complex emergent behavior of something which otherwise takes an enormous amount of metacognitive effort to understand. The limitless potential of this dream space we are now starting to call the metaverse is an attractive place for some, but for others it's superficial and fake. As cyberspace expands, the meaning assigned to this place becomes increasingly ethereal and diluted. People come to realize that, ironically, despite the limitless potential cyberspace, it remains extraordinarily limited. It is capable of producing anything our imaginations are capable of thinking of, with one glaringly important exception: something real. Our computers can produce symbols, sounds, synaptic feedback, and complex emergent behaviors. Through false positive correlations and abstract thinking, people hypostatize the sights and sounds produced by these machines as if they were concretely real things. This learned habit of hypostatization doesn't mean that anything we see in cyberspace is physically real. What humans see online is nothing but synthetically generated images on an array of light-emitting diodes they put into their offices or carry around in their pockets. What humans hear online is synthetically generated air pressure waves produced by plastic cones. In other words, speakers. Even our newly developed synaptic feedback systems are synthetically generated by some computer programmer who has control over that synaptic feedback system. Our computers never stopped being general-purpose state machines, which produce artificial symbols and sounds and complex emergent behaviors via state changes. Without proof of real protocols like Bitcoin, these state changes are materially inconsequential, trivial to reproduce, thermodynamically unsound, and carefully designed by software engineers to present the illusion of something real, but isn't actually real. We see and hear the same things online because our computers have been programmed to role-play the same things back to us. These computers are connected together and highly synchronized, producing artificial sensory inputs which feed our brains the same programmed sights and sounds. Once we receive these artificially produced signals, our neocortices apply the same abstract meaning to the same objectively meaningless and materially inconsequential patterns produced by these machines, creating a new form of shared abstract reality that we can see and explore together, a virtual reality we have named cyberspace. And behind all these illusions are computer programmers who control them. Computer programmers we must trust not to exploit us with their ability to conjure these illusions. The cyber stories we see online are entertaining and informative, but if we examine our behavior strictly from the perspective of shared objective physical reality, then we can see that all we are doing is behaving like an audience of people watching electromechanical marionettes acting out the same fictional performance for us. As we increasingly adopt the habit of ignoring the people who are pulling the strings of these marionettes, it becomes easier for us to believe that what we are seeing is something other than a well-orchestrated performance that was explicitly designed by someone in control over the illusion. Basically a digital age version of Plato's allegory of the cave. This makes us gradually less capable of seeing that we can, and probably are, being oppressed by those who control these illusions. Computer programmers and software system administrators are harvesting our data. They are experimenting on us to learn what drives our behavior, and they are using this knowledge to further their own agendas. It seems that we are beginning to lose sight of the lesson that the boy monk from the Matrix gave to Neo. There is no spoon. Operating in, from, and through cyberspace is akin to operating in a dream state with no time, energy, space, or mass. Or in Sailor's words, it consists only of shadows and ghosts. Behind each computer-generated illusion is a person or organization who controls that illusion. A person or organization we must implicitly trust not to conjure illusions which manipulate us for their own benefit. This trust is necessary because without proof of power, aka proof of work, protocols like Bitcoin, we neither have the ability to detect what's real, nor do we have the ability to physically constrain those who might seek to manipulate us through the illusions they can conjure on our computer screens. The simple truth of the matter is that the world we see when we operate in, from, and through the current version of cyberspace exists in the human imagination only. The videos people watch, the text people read, the comments they see, the ads and images they encounter, even the results they get when searching for something, are all carefully and deliberately programmed by computer programmers, who wield unprecedented amounts of abstract power and control authority over people by virtue of their control over people's computers. Almost nothing about what people experience on the internet is random or even serendipitous anymore. All of it is being meticulously programmed by people who enjoy physically unrestricted control over billions of people's computers. That notification you got in the morning for a smoothie coupon was not serendipitous. Your apps continually harvest your phone's data and sell it to advertisers who know where you live, where you work, the routes you take, and the fact that you're going to be passing by that smoothie place you like in approximately 15 minutes. You are being manipulated. As people operate increasingly more in cyberspace, they find themselves with a unique problem. Everyone online is participating in a shared abstract illusion where people have no way to verify if anything they're experiencing is linked to anything objectively real or even materially substantial. Practically all of the most popular software we rely on is attempting to influence our patterns of behavior for the personal benefit of that software's administrators. And they get away with it because there's currently nothing anchoring cyberspace to objective physical reality. Nothing applying physical or thermodynamic restrictions on them. It's impossible to verify if anything seen online has real-world physical properties, because people don't have the ability to poke or pinch anything. They have no proof of power protocol. At the same time, They are completely subject to the whim of the storytellers writing the scripts, the people pulling the strings, with no way to physically restrict them from global-scale systemic exploitation of cyberspace. Bitcoin potentially fixes this. With the arrival of open-source and globally scalable proof-of-power protocols like Bitcoin comes the arrival of a globally adoptable proof-of-real protocol. If a person wants to claim that their cyber abstraction has physically real or materially consequential properties like physical cost, scarcity, or decentralization, they can now prove it using bits of Bitcoin. Otherwise, people have no ability to verify that what they see in cyberspace is anything more than just another illusion floating in an infinitely expanding sea of marginalized illusions, trying to expropriate a population's most valuable bits of information, their behavioral data, and sell it to the highest bidder. The point is, proof-of-power protocols have metacognitive properties that could transform how people perceive and behave in cyberspace in ways that we can't yet comprehend or fully appreciate because this technology is so new. To the author's knowledge, these pages represent the first time someone has even attempted to discuss these concepts together in formal academic literature. How humans perceive real is directly dependent on finding proof of power. Proof of power signals produced by physical cost function protocols like Bitcoin could theoretically double as proof of real signals to serve as the same function as kinetic power. In other words, poking and pinching. When abstractions in cyberspace are accompanied by verifiable proof of real signals, they can have verifiable physical characteristics, unlike any other abstraction in cyberspace, bringing what Saylor called the conservation of energy and matter, objectivity, truth, time, and consequence into the digital realm. At the same time, proof of power could also be used to legitimize or delegitimize computer programmers, who otherwise have unrestricted abstract power and control over the illusions we see in cyberspace. Section 5.9.9 Adding a physically constrained and thermodynamically restricted space to cyberspace. Combining these different theories together, we can see what advantages could be gained if someone figured out how to create a protocol which allows people to plug a planetary-scale computer into the Internet. Bitcoin is special because it could represent the global adoption of the operating system for a planetary-scale computer, which converts our global electric power grid into a globally decentralized state mechanism under nobody's centralized control, that everyone on the planet is capable of operating in a zero-trust and permissionless way, so long as they're willing to project power. This planetary-scale computer would theoretically be capable of adding a unique and one-of-a-kind state space to cyberspace, in comparison to the existing state space created by ordinary computers. This special state space would function as its own physically constrained and thermodynamically restricted space that no other state space in cyberspace could replicate, offering reverse-optimized properties that could be very useful for many different applications, particularly ones related to cybersecurity and keeping people safe against population-scale systemic exploitation and abuse of the Internet's existing architecture. The special state space created by a planetary-scale computer would be more materially consequential than other state spaces in cyberspace, and people could use it to impose severe physical costs on other people by simply requiring them to operate or pass through this space. This state space could also link our surrounding physical environment to virtual reality in a way that previously wasn't considered possible, providing cyberspace with emergent properties that are physically impossible to reproduce using ordinary computers operating on the legacy, physically unconstrained, and thermodynamically unrestricted version of the Internet. These concepts are illustrated in Figure 81, theoretical effect of plugging a planetary-scale state mechanism into the Internet. As of now, these ideas are nothing more than theories grounded by the author's first principles approach to exploring the benefits of proof of power, aka proof of work, protocols. However, if further scrutinization of these theories indicate they could be valid, then it's hard to understate the strategic value of the state space created by systems like Bitcoin. The bits of information passed across the Bitcoin system would represent bits of reverse-optimized information transferred, received, and stored by a planetary-scale computer. Bitcoin's coins would represent the underlying state space of this planetary-scale computer, an extraordinarily unique and strategically advantageous space within cyberspace. This would be similar to how there are unique and strategically advantageous positions inside of other domains. Just like canals and ports are strategically valuable spaces in C, or Lagrange points are strategically valuable spaces in outer space, the physically constrained and thermodynamically restricted space of cyberspace could become among the most strategically valuable resources of the digital age. Owning a bit of Bitcoin's coins, which, if the theories presented in this thesis are valid, is really just an arbitrary name assigned to the bits of information transferred and stored across a planetary-scale computing system, could represent owning an irreproducible piece of novel cyberspace created by society's first globally adopted planetary-scale computer. Moreover, because global leaders don't understand computer theory well enough to understand the term Bitcoin is purely an arbitrary name, or because researchers aren't taking these theories seriously, this could mean that nation-states are allowing themselves to become among the last institutions to establish a foothold in this potentially strategically vital space within cyberspace. This could upturn global power projection dynamics and dramatically restructure the digital age geopolitical environment, exactly as planetary-scale computing theorists predict will happen. Section 5.9.10 Applying the Strangler pattern to the Internet itself, starting with financial microservices. It is possible that in the future, people will not value objects in cyberspace unless they're anchored to our physical objective reality via verifiable proofs of work. Another way of saying the same thing is that in the future, people may not trust or value bits of information that are transferred and stored in cyberspace unless those bits of information are specifically derived from the planetary scale computer. In fact, this is already starting to happen, as people have already started to not trust or value financial bits of information unless they're derived from the Bitcoin computing system, which the author theorizes doubles as the operating system of the world's first operational planetary scale computer. Why would people not trust or value bits of information that haven't been physically constrained or thermodynamically restricted? Simply because they would not be anchored to anything verifiably real or materially consequential. People might one day come to understand that everything they encountered in the so-called metaverse is something physically unconstrained, thermodynamically unrestricted, materially irrelevant, and under the complete, unimpeachable control of some technocratic ruling class, who can, and probably already is, exploiting these unconstrained and unrestricted bits of information. One day, civil society may learn that if they want to physically constrain and decentralize people's control over their computers in order to mitigate global-scale systemic exploitation and abuse of the internet, they will have to learn how to utilize real-world physical power, aka watts, to countervail the imaginary power of their neo-god kings, aka software administrators. The same way agrarian society has always had to utilize real-world physical power to countervail the imaginary power of their god kings. Physical power has always been both the antecedent and the antidote to imaginary power. New physical power projection protocols like Bitcoin appear to be integral to the same power projection game agrarian society has always played, but in a new domain where digital age society is spending increasingly more of its time. If this cultural evolution were to occur at large enough scale, then the special state space added to existing cyberspace by systems like Bitcoin could one day become recognized as the foundational layer of the internet, which grounds cyberspace to the physical constraints of shared objective material reality. This new, physically restricted version of cyberspace could become universally recognized as a place where computer programmers, with their immense abstract power and physically unconstrained control authority over people's computers, can no longer use it to exploit people's bits because it's too physically expensive. It is theoretically possible that people might start making a clear and pronounced mental distinction between two different versions of cyberspace, with two very different kinds of bits of information transferring across them. One version of cyberspace would be physically secure against a technocratic ruling class of computer programmers and software administrators, who have already demonstrated that, when left physically unconstrained, can and will deny people's bits, harvest people's bits, use people's bits to learn how to affect their behavior, and use what they learn to exploit or influence the behavior of entire populations at unprecedented scale. The other version of cyberspace would be the original version of cyberspace that we know today, the version of cyberspace where people don't have the ability to physically secure their bits of information because they have no ability to impose severe physical costs on people in, from and through cyberspace, who try to deny their right to transfer bits, or who try to exploit them in many other ways, thanks to their having centralized control over those bits. In the newer version of cyberspace that is backed by proof of power, things would have verifiably real-world physical properties like scarcity and decentralization that would be physically impossible to replicate in the older version of cyberspace created by ordinary computers. In the new version of cyberspace, programs wouldn't be allowed to execute certain control signals unless they're backed by substantial proof of power, thereby physically constraining the reach and control authority of software-designed abstract power hierarchies. This would be a stark contrast to the older, original version of cyberspace that is notably lacking proof of power, where all software abstractions would continue to not have verifiably real-world physical properties. In the legacy version of cyberspace, the abstract power and control authority of software-defined abstract power hierarchies would continue to remain physically unconstrained, and all of the clear systemic security challenges we have today would remain the same, because the underlying architecture of the Internet would remain the same, namely the inability to impose severe physical costs or physical constraints. In the future, proof of work, aka proof of power, aka proof of real, aka physical cost function protocols like Bitcoin, to repeat, the name we give it is arbitrary, could serve as the dominant mechanism used by digital age societies to map or anchor elements of the legacy version of the Internet to the new version Internet, thereby serving as the world's globally adopted proof of real protocol. Regardless of whatever arbitrary name people give to protocols like Bitcoin in the future, the point is that this system could become instrumentally more important than only a financial system. Bitcoin has the potential to become integral to the development of a completely new internet infrastructure and a completely new type of cyberspace. It is possible that what we are seeing with the global adoption of Bitcoin represents a strangler pattern playing out for the existing internet architecture. We could be modernizing a large, monolithic computing system right now by gradually replacing services performed on the legacy system with services performed on the modernized system. And it could just be that financial information exchange simply represents the first of many microservices to be performed on a modernized architecture of the World Wide Web.